To understand the concept of free entry and free exit into and out of a competitive market and how this leads to zero economic profits in the long run, it helps to consider both the graphs for the entire market of a product and the graph of a single producer in that market simultaneously. So let's pretend this is the market for coffee, a typical commodity. We begin by drawing the marginal cost curve for one individual producer of coffee. So this is the marginal cost of producing coffee for this one coffee producer. Our coffee producer's goal is to maximize his profits, and this is going to occur when he follows the rule of setting his quantity of production where marginal cost equals the marginal revenue. Okay, that's how he's going to figure out how much coffee to produce. The marginal revenue is simply the revenue from a marginal unit of output produced. That means for every pound of coffee, what is the price that the producer can fetch in the marketplace? Okay, so marginal revenue is equivalent to the price that the seller can sell at. Okay, so suppose that the market price is down here. So let's say the market price is $5 per pound of coffee. Okay, so the producer is going to follow this rule of setting marginal cost equal to marginal revenue in order to determine how much coffee to make and produce. Okay, so marginal revenue of $5 equals marginal cost right there. Okay, so this happens at this quantity of production. I'll call it Q star 1. If our coffee producer is making less than Q star 1 pounds of coffee, then the marginal revenue for those pounds of coffee is higher than the marginal cost. And so he has an incentive to keep increasing production as long as the benefit outweighs the cost. Okay, once he gets to Q star 1, the benefit and cost equal each other. And if he were to keep producing beyond Q star 1, then the cost would now outweigh the benefit, and this would no longer be rational for our producer. Now, if for some reason the coffee producer can sell his coffee for more, let's say $8 per pound instead of $5, okay, now he's going to find it optimal to produce more coffee. So now this marginal revenue line, or the price, is going to equal marginal cost at a higher level of production. We'll call it Q star 2. By following the rule of setting marginal cost equal to marginal revenue in order to determine how much to produce, this coffee producer is maximizing his profits. But that doesn't necessarily mean he's making positive profits. So he could actually be making negative profits. He's just making the least negative profits possible. Or it might be the case that he's making actual positive profits. Okay, so to determine which of those situations the coffee producer falls into, we need to consider more than just the marginal cost of production. So the marginal cost of production takes into account how much it costs to produce one more pound of coffee. So the marginal cost of production is going to take into account how many more workers he needs to hire, how much more fertilizer he needs for his fields, and so forth. But it's not going to take into account his overhead cost, his fixed costs. So perhaps his fixed cost is the rent he pays on the land that he's growing his coffee beans on. Let's say the farmer rents 5 acres of land, and whether he only plants half an acre or the full 5 acres, he still has to always pay rent for the full 5 acres. So this is a fixed or overhead cost. Now, if we incorporate all the overhead or fixed costs and the incremental or marginal cost, we get the total cost of production for the farmer. And if we look at it on a per unit case, we get the average total cost. So incorporating that into our graph, we can draw an average total cost curve that looks something like this. And there's ATC for average total cost. Now, much of the average total cost curve is increasing, and this largely reflects the increasing marginal cost of production as well. So I won't go into detail about explaining that. But why is the average total cost curve decreasing to begin with? Well, this has to do with that overhead or fixed cost that I mentioned previously. So in this particular example, we were thinking of the overhead costs as the rent that the coffee producer is paying on the 5 acres of land on which coffee is being grown. So whether he's growing almost no coffee or a whole lot of coffee, he still has to pay rent on that 5 acres of land. So this average cost curve is going to take that entire overhead plus any marginal costs and divide it by how much coffee is being produced. So when little coffee is being produced, maybe he's only using like a third of an acre as opposed to the full 5 acres, but he's still paying for the full 5 acres. As he produces more and more coffee, that 5 acre cost is diluted over more and more pounds of coffee. And so that average decreases as more and more is produced. To summarize, initially the average total cost curve is decreasing because the overhead or fixed cost is being diluted over an increasing quantity of product, but eventually that effect is overtaken by the increasing marginal cost of production, and so our average total cost curve increases thereafter. We're now ready to determine whether this coffee producer is making a positive profit, zero profit, or a negative profit. Profit is equal to the total revenue the coffee producer collects minus his total cost of production. Or, in other words, we can look at the revenue he collects for each pound he sells, which is just the price he fetches in the marketplace for each pound, minus the average total cost of each pound he produces. So when he's producing Q star pounds of coffee, this is his average total cost per pound. Okay, and in this case, it's lower than the price he fetches. So let's say this is $3 per pound in costs compared to $5 that he's selling each pound for. So in all, he's making a positive profit because each pound sells for more than it costs to produce. And this rectangle here gives us the overall profit. Price minus cost times the quantity of coffee sold. Now the next question is, where did this price of $5 come from? That is, how did the coffee producer know to sell his coffee at $5 a pound? Did he pick it out of thin air, or is there some more systematic manner in which he determined this price? Let's rewind a bit. Now, this coffee producer is just one of the many coffee producers in the entire market for coffee. Okay, so this is this producer's particular marginal cost curve, which tells us the cost structure for this particular producer. But the marginal cost curve could be different for different producers. And if we combine all of the marginal cost curves for all of the coffee producers, we get the market supply curve. So here is our market supply curve, which consists of the many coffee producers in the market for coffee. On the other side of the market are all the consumers of coffee, all those coffee drinkers making up the demand for coffee. We've seen before how the interaction between the supply side and the demand side of the market brings us to an equilibrium market price, P star, and an equilibrium quantity of our product bought and sold, Q star. Right, so in this market for coffee, we have a market equilibrium giving us the market price and telling us how much coffee is bought and sold. And now our one individual coffee producer out of many doesn't have any market power, meaning he can't influence the market price, which is determined over here in the overall market. This coffee producer must charge P star for his product. If he charges anything higher, he's going to lose all his consumers, all his buyers, because there are all these other coffee producers making the exact same product, and customers can simply go to one of these other producers if our coffee producer decides to charge a higher price. He wouldn't want to charge a lower price than P star because, as will become clear in a few minutes, this would lead him to get negative profits in the long run. In a competitive market, our single producer is a price taker, meaning he doesn't determine the price, he just looks at the market and takes that price as given. So I'm going to draw a straight line from the market, where the market price is, all the way into the single producer's graph. Okay, so this is what we call the marginal revenue line of the producer. In other words, it's just the price that he can sell each pound of coffee at. And we know that he needs to follow this rule of setting marginal cost equal to marginal revenue when deciding how much coffee to produce. And this will give him the highest profit possible. So doing that, marginal revenue equals marginal cost at this level of production right here. We'll call it little q star. Okay. And every producer is doing this, and every producer has their own q star. Okay, that's going to depend on what that producer's cost of production looks like. And all the q stars for all the producers added up will give us our big q star in the market over here. Let's see how our single coffee producer is doing profit-wise given the current market price. So to determine whether our producer is making a positive or a negative profit, we need to incorporate our average total cost curve like we did earlier. So let's say it looks something like this. There's our average total cost curve. Okay, so at a production level of Q star, the average cost per pound of coffee is right here. Okay, and we see that our coffee producer is in fact making a positive profit because the price that he's selling each pound of coffee at is greater than the cost of producing each pound of coffee. And this rectangle represents that profit. Now, what tends to happen in a competitive market is that these positive profits that are being made by our producer and probably many other producers is that it entices new entrants into the market. That is, it entices new coffee producers to open up shop. Okay, so when this happens, it's going to increase the overall market supply of coffee, shifting out our supply curve. So we'll label this new supply curve S2. Okay, so at the prevailing market price, we're now no longer in a market equilibrium because the demand for coffee is down here, but now the supply is way out here. Okay, so this excess supply is going to drive down market price, and we're going to move along the demand curve and along the new supply curve until we get rid of that excess supply, until we are back to an equilibrium, in this case at Q star 2. And the new equilibrium price will occur at P star 2. Okay, so now our coffee producer over here needs to reassess what he's doing, how much coffee he's producing. The market price has changed, and therefore price is not going to equal marginal cost at the same level of coffee production. He needs to determine his new Q star. So he does that by taking the new market price and setting it equal to his marginal cost. Okay, so there's where it hits the marginal cost curve. And here's his new optimal or profit maximizing level of output, Q star 2. Okay, so let's see what happened to our producer's positive profits when the market price fell. Okay, so looking at his average total cost at Q star level of production, we see that the average total cost is now just equal to the market price, meaning that our producer is just breaking even. This whole rectangle of profits he was making before has disappeared. Because of free entry into the marketplace, a key feature of a perfectly competitive market, profits are going to be driven to zero over time. Suppose that instead of originally making a positive profit, our producer of coffee over here was making a negative profit to start with. So the average total cost curve would look something like this. Where at Q star, the average total cost of production would be up here, clearly higher than the price that the coffee producer is able to sell his product at. So the profit would be negative in this case. Price per pound is down here, cost per pound is up here. So this rectangle would represent the loss to our coffee producer, the negative profit he's making. Presumably, he's not the only coffee producer that's making a negative profit when the market price is at its current level. And let's suppose that our coffee producer sort of sticks it out for a while, and some of the other coffee producers that are making a negative profit decide to close up shop. They're able to get out of the lease for the land that they're paying rent on, and they're able to get rid of all their farm equipment and so forth, and they get out of the market. Okay, what's going to happen in the market for coffee is that the supply curve's going to shift inward. Okay, as some of those coffee producers leave, supply becomes lower. And so the market price is going to have to adjust to reflect this new smaller supply of coffee production. Okay, so at the original market price, we're now in a disequilibrium. The demand for coffee is way out here, but the supply of coffee at that price is way down here. And this creates a shortage of coffee. A shortage is going to drive up the cost of coffee, moving us along our demand curve and along our new supply curve until the shortage is no longer. That is, until we're back in equilibrium. And that'll occur where the new supply curve meets the original demand curve. We'll have a new equilibrium quantity, Q star 2, and a new equilibrium market price of coffee, P star 2. Our coffee producer over here is still fretting about these negative profits, but he hasn't closed up shop yet, and he's noticed that the market price has started increasing. So as the market price increases, he needs to adjust the quantity of coffee that he's growing and selling. He needs to figure out his new Q star by setting marginal cost equal to the new marginal revenue, the new P star. So we're going to draw a line from the market, this market price, and we're going to set it equal to the marginal cost of production. And this is going to occur at a higher quantity of production for our coffee producer, Q star 2. And now let's see what happened to these negative profits. Okay, so at this new level of production, the market price and the average total cost are just equal. And so our producer is now breaking even. He's no longer making negative profits, he's making zero profits. Because a lot of the least profitable producers exited the market price went up some, which allowed our producer to stay in business. And overall, it drove his profits to zero. To recap, in a perfectly competitive market, free entry and exit in and out of the market by producers is going to lead to zero economic profits in the long run.